Hello and welcome back. In this video we'll look at the next homework assignment on fractions. And to begin with, we should all recognize that fractions are just numbers. So just like the number 2, 7/3 represents a number, an amount of something. 5/10 represents a number. It's just an amount of something. So with fractions, we can, or with any numbers, we can multiply them, add them, divide them, subtract them. We can do anything that we really want with them. And in this video, we're going to focus on multiplying and dividing fractions. But to begin with, we want to recognize that there's more than one way to write a number. So for instance, if I write the number 6 down, I could say 6 and maybe you say 2 times 3. And we're really saying the same number here. And with fractions, it's the same way. If I said 12 divided by 2, you can recognize that if I say 12 divided by 2, as in the fraction 12 halves, it is just the number 6. So there's more than one way to write a number, especially with fractions. And we'll just recognize that fractions are division. So what we can do is we can what's called reduce fractions, so that there's no more easy divisions left to do. So how do we do this? I think the best way is to look at an example, and then I'll explain exactly what's going on. So with the number 6/9, we're taking the number 6 and we're dividing it by 9. However, what I can do is I can pull the 6 apart, and I'll see that it's actually 2 times 3. 2 times 3. And on the bottom, I have 9, which I can write as 3 times 3. And if I'm going to take 2 times 3 and then divide it by another 3 times 3, what we'll have is 1 3 on top will cancel out with 1 3 on the bottom, and we will be left with 2/3. So why does this happen? Well, it's the following fact. Multiplying and dividing are opposites. They essentially they undo one another. So if I had a number, if I'm just thinking of a number 7, and then I multiply it by 2, and then divide it by 2, well, if I multiply something by 2 and then divide it by 2, I just get 7 back. And it's the same way up here. I have some numbers, I end up multiplying by 3 on top, because the top refers to multiplication. The bottom, I'm dividing by 3. This is what happens to numbers that are on the bottom of the fraction. So because I'm multiplying and dividing by 3, they cancel. So ultimately, we'll just find factors on the top and bottom that are the same, so we can cancel them out. Let's just do more examples. More examples is always good. Let's take some bigger numbers, 72 and 42. So I want to pull apart the top of the fraction and the bottom of the fraction and start canceling numbers. So the first thing that I'll notice is that the top is an even number, so it's divisible by 2. And it turns out that 72 is actually 2 times 36. The bottom of the fraction is also even, so I can divide that by 2. So 42 is going to be 2 times 21. And look, I've got a 2 on the top and a 2 on the bottom. I can cancel those out, and I'm left with 36 21sts. Now, am I done? Well, not quite. If we look at this some more, we'll see that 36, I can divide that by 3, for instance, and the 21, I can also divide this by 3. So what is 36? 36 is going to be 3 times 12, and 21 is going to be 3 times 7. So again, I can cancel a 3 off the top and a 3 off the bottom to get 12 sevenths. So then we can ask, okay, is 12 sevenths reduced? Is this as far as I can go? And the answer is yes, but maybe it's not obvious. How can I tell if 12 sevenths is as far as I can go? What I can do is I can take 12 and I can break it apart as much as I can. Go all the way down to prime numbers. So here, if I take 12, I can write 12 as, for instance, 2 times 6. Okay, so far so good. But 6 I can also break down. This is going to be 2 times 3. And if we think about it, yes, 12 is 2 times 2 times 3. 2, I can't break 2 down anymore. I can't break 2 down anymore. I can't break 3 down anymore. This is as small as it gets. Also, the number 7, I can't divide the number 7 by anything. I can't divide it by 2, by 3, by 4, by 5, by 6. 7 is a prime number. So when I look at this, I can't cancel any 2s or 3s out with the 7. So I'm done. So this is reduced. And the one thing is that I can do this from the very beginning as well. And this, for some people, is really helpful. So let me go through this process. If I started from the beginning and I started with 72, I can go 72 is going to be 2 times 36. And then 36 is going to be 2 times 18. 18 is 2 times 9. And 9 is 3 times 3. And all of these numbers I can't break down anymore. I can't break 2 down anymore. I can't break 3 down anymore. So let's do the same thing with 42. So with 42, again, this is going to be 2 times 21. 21 is going to be 3 times 7. And again, I can't break the 2 down anymore. I can't break the 3 down anymore. I can't break the 7 down anymore. So so when I come back up here, what you'll see is I canceled out a 2 first, and then a 3. Well, here are 72 and here are 42. And I've canceled out 1, 2, and 1, 3. 1, 2, and 1, 3. What am I left with? 2 times 2 times 3, which is 12, and 7, which is 7. So here, it can be useful to break down the entire number first and just look to see, oh, I've got a 2 on the top and the bottom, and I've got a 3 on the top and the bottom. Whatever's left is whatever's left. Let's just go through more examples. Good. So here we've got 200 divided by 220. The first thing that I notice is that both these numbers have a 0 at the end. So I can divide them both by 10. So the top is going to be 20 times 10. The bottom is going to be 22 times 10. And again, I can cancel the 10 off the top and 10 off the bottom. So what I'm left with is going to be 20 divided by 22. Both the top and bottom are even numbers, so I can divide them both by 2. The top is going to be 2 times 10. The bottom is going to be 2 times 11. So I can cancel the 2 out, and I'll get 10 divided by 11. 10 is going to be 2 times 5. 11, I can't divide 11 by anything, so I can't cancel anymore because I can't cancel the 2's and 5's on top with the 11 on the bottom. So this is reduced. So reducing fractions is quite helpful. One quick aside, if you ever see a number, if you ever reduce a fraction and it's being divided by 1, this is fine, this is perfectly valid. But whenever we divide something by 1, it's also just equal to 2. Dividing something by 1 doesn't do anything to the number, just like multiplying by 1. So reducing fractions, it just takes a lot of practice, which is why we're in this class. So what will come next? We're going to multiply fractions and then divide fractions next. So multiplying fractions, there's just a couple steps. We multiply the tops of the fractions, called the numerators. So the numerator is the top of the fraction, and we'll multiply the bottom of the fraction, which are called the denominators. So again, let's just go through a bunch of examples. So we've got 2/3 times 3/4. And there's a couple of ways to do this. I'm going to do this fairly directly. So when we multiply fractions, we're going to multiply the tops of the fractions and the bottoms of the fractions, and then leave them where they are. So for instance, on the tops of the fractions, we've got a 2 times 3. And then on the bottom of the fraction, we've got 3 times 4. And before I actually multiply these out and get 6 and 12, what we'll notice is that I'm multiplying by 3 on top, and I'm multiplying by 3 on the bottom. They cancel. So what I'm left with is 2/4. But this doesn't quite seem right, does it? Because we can still reduce further. The top is going to be just 2. The bottom is going to be 4, which is 2 times 2. So I can cancel a 2 off the top and a 2 off the bottom. But it doesn't look like there's anything left on top. If we've canceled everything off the top or everything off the bottom, it doesn't matter which side, if we cancel everything, what's left is just 1. So on the bottom, we're left with a 2. On the top, after we've canceled everything, we're left with a 1. So this is what we get when we multiply these fractions and reduce. Let's do that again with a few more examples. So we've got 14 fifteenths times 3 sevenths. Again, we'll just multiply the top. So it's going to be 14 times 3. And the bottom is going to be 15 times 7. And again, I could multiply 14 times 3 and write it down. I could multiply 15 times 7 and write it down. I'm not going to, because it's going to be a little bit easier to cancel, to reduce, if the numbers are pulled apart. So up top we've got 14 and 3, on the bottom we've got 15 and 7. I go, oh, wait a second, I can pull 15 apart. You get a 3, because 15 is 3 times 5, so there's a 3 on the top and the bottom. Okay, so that's useful. So 15 is going to be 3 times 5, and then we still have the 7 on the bottom. But, oh, we've got a 7 on the bottom, we've got a 14 on the top. 14 is just 2 times 7. And we can start canceling things down. So we've got a 7 on the top and a 7 on the bottom. Also got a 3 on the top and a 3 on the bottom, and what we're left with is 2 fifths, which I can't reduce this anymore. 2 isn't divisible by anything, 5 isn't divisible by anything, so if I can't cancel them directly, there's nothing left. And let's do one more multiplication down here. We've got 21 eighteenths times 3 halves. Again, I'll take 21 times 3 and 18 times 2. This dot here just means multiplication. There's different ways to write multiplication. Sometimes you'll see dots, sometimes you'll see the little X there. So we've got 21 times 3 on top, 18 times 2 on the bottom. The 21, I can split that apart. I can split the 18 apart. And what we're looking is for things to cancel. So I've got a 3 on the top. Well, 18 is divisible by 3. So let's split that apart. If I divide 18 by 3, I get 6. This is going to be 3 times 6 times 2. And then the top, I'm going to, so maybe we should split the 21 apart as well. So 21 is going to be 3 times 7. And we still have that times 3. So let's see if we can't cancel some things. Well, I've got a 3 on the top and a 3 on the bottom. And, oh, we've got a 3 up here and a 6 on the bottom. A 6 I can pull apart into a 2 and a 3. So we'll cancel the 3's. On the top, we still have the 7. We still have the 3. On the bottom, our 6 we can pull apart into 3 times 2. And we still have that last times 2. We can't forget about that last one. And I can cancel the 3 on the top and the 3 on the bottom. The 7, I can't split that apart anymore. I can't split 2's apart anymore. And 7's and 2's don't cancel. They're all the same number. So we get 7. And then on the bottom, it's 2 times 2, which is 4. What you'll notice is that this is called an improper fraction, as in the numerator at the top is bigger than the bottom. That's absolutely fine. I think it's quite often easier to leave these as improper fractions. And in the next video, we'll go through dividing fractions.